here they play a game with n piles of stone, where the ith pile has a number of stones initially. Now, on the Alice's turn, she'll be picking two indices which have the same parity, and she'll be removing that stone from both the piles. And on Bob's turn, he will choose indices of different parity, and he will move one stone from the ith pile to the jth pile. Now, whoever is not able to make a move, they will be the loser of the game, and we have to determine the winner of the game if both of them play optimally. Right. Now, the first and major observation for this problem is that Alice and Bob don't care about the indices actually. So Alice doesn't care whether she is picking the elements from 2, 4 or 4 and 6, but all she cares about is whether she is picking the elements from the same index. And so is Bob. So Bob doesn't care whether he is taking the elements from 1 and 2 or any other different indices. So all he cares about it whether he is able to pick indices from different indices or different parities of indices. Primary observation to solve this problem is to just understand that we don't care about the actual indices. So all we care about is whether it has odd parity or the index is of even parity. So if we have an array which has the values as 2, 1, 3, and 4, we'll just try to group the elements which occur at even indices and the elements which are occurring at odd indices separately. So the elements at the odd index is 2 and 3 if you take in one based indexing. So the number of elements at the odd index is 5 and the number of elements at the even index is also 5. So if this value had been 2, then we'll be getting the number of elements at the even index as 2 plus 1, which is 3, right? So at first we'll be trying to combine the elements which are there at the odd indices and even indices separately. So this is the primary observation for this for solving this problem. So shall we just try to construct the answer from scratch? Let's go step by step. At first we can go to the case of 0 and 1 and we can find out the answer. Now if this is done, then I could go to the next case. There is the sum of the values being 2. So the values could be 1, 1 and then 0, 2. Right. So these two cases have the sum of the elements as 2. And this is the case which we have, which has sum of the elements as 1. Now we could get the answer for these two cases. So if this is done, then we could go to the next case where the sum of the elements is 3. So in that case, the combinations are 0, 3 and 1 and 2. Now, just take this case for example. So Alice will be starting this game, right? So in that case, she'll be taking 2 elements out of it. So the next combination will be 0, 1, and this has already been calculated over here. Now, even in this case, if Alice takes 2 from the second parity, then we'll be getting the combinations 1 and 0, which has already been dealt with previously. So if we try to construct the elements from scratch, that is from the sum as 1, then we could find out the answer or we could find out the pattern for this particular problem. So this is exactly what I have done over here. So this is a sum that is possible, and for every sum I'll be figuring out all the cases that are possible. There is the case with which we can construct that particular sum, and I'll be just figuring out who can win that particular game, right? So for 1, the combination is 0 and 1. So if Alice starts the game with 0 and 1, Bob will be winning that particular case. Now the combinations for 2 are 0, 2 and 1 and 1. That is, if we take the sum of these two values, then we'll be getting the sum as 2. Now for this particular case, that is, if Alice starts with 0, 2 as the combination, then Alice will win the game. But on the contrary, if Alice starts with 1 and 1, Bob will win the game. Let's just try to figure out some patterns for this. So whenever the sum is odd, all the cases are being won by Bob. So in the case of 1, 0 and 1 is being won by Bob. And in the case of 3, all the things are being won by Bob. So whenever the sum that we have is an odd number, then the answer will be Bob. Right. Now let's try to figure out some pattern for the even sums. So this case of even sums is a bit trickier. Right. So at first let's take out the half of all these values. So it will be 1 and the half of this one will be 2 and the half of this will be 3. Now just compare the parities of these values and then the values that you have. So inside these brackets, if you see, all these values will be having the same parity. We can get an even sum only in the case of odd plus odd or even plus even. So the elements inside the brackets will always have the same parity, right? So now let's compare the parity of this element with the elements that are present inside the brackets, right? So if you see, the parity of one is odd, and the odd elements will be 1 by Bob. So in this case, the when we took the half of the elements, we got the answer as 2. The parity of 2 is even, right? Now the even combinations of this particular 4 will be 1 by Bob. So what are the even combinations? So it's 0, comma 4 and then 2, comma 2. So the even combinations are being 1 by Bob. Now same is the case of 6. So the 6 half is 3 and 3's parity is odd. So the odd combinations will be 1 by Bob. So the odd combinations for 6 are 1, 5 and then 3, 3. And then the opposite parities will be 1 by Alice. So if the answer is 3, so the parity will be odd. Then the opposite parity, that is even parity cases, will be 1 by Alice. Let's check out the code for this problem. So at first I'm grouping all the even indices and odd indices separately, and I'll be having the sums and odd sum and then even sum. And the total sum will be the combination of these two things. So it will be even sum plus odd sum. So there is an edge case which I forgot to tell. So if n is equals to 1, there is, if you have only one element as such, then if the value is greater than 1, then Alice can reduce that move and she'll be giving that to Bob. But Bob at least has to select two indices of different parities, right? So there is no different parity when there is only one element. So if the total sum is equals to 1, then even Alice cannot make a move, right? So in that case, the answer will be Bob. Otherwise, the answer will be Alice. Now let's discuss for the other cases. So at first, I'll be checking the parity of the total sum. So if that's odd, then I'll be directly declaring the answer as Bob. Otherwise, I'll be calculating the half of the sum. And if the parity of half and then the even sum or odd sum is matching to each other, then Bob will be the answer. Otherwise, the answer will be Alice. So this is the solution for the third problem.